Today we're going to explain how BCD function and how BCD translates to 7-segment decoder. After that, we're going to design a 7-segment decoder from BCD using K-map. Okay, so I have conducted my research beforehand. The 7-segment display is used to convert digital signals into a visible display called segments. It is used to display a single decimal digit driven by the binary coded decimal display or BCD, and these segments are represented by 7 light emitting diodes, 1 2 3 4 5 6 7, and sometimes there is an 8th LED, or depending on the module that you will use. So what is a BCD? A BCD, or a binary coded decimal display, is a numerical code that has the binary numbers or digits to represent a decimal number. A decimal number contains 10 digits, which are 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So that we can use the binary numbers from 0000 to 1001 only, which are the decimal equivalent of 0 to 9. So how do we display a digit using the BCD code? Using a simulator, we can display a digit using the BCD code that is represented by zeros and ones. As you can see, if you apply these segments directly, this is how the output would look like. 0, by the way, means low voltage and 1 means high. So each of these nodes are connected to a certain switch. We'll just put a label on each segment or LED, and these nodes are connected or wired to these switches. So sometimes we have a DP, or the decimal point, which is always here. The node is connected here. So as you can see in this graph, or in this diagram, the switches or voltages are 0, which means low voltage. So the segments are still turned off. The LEDs are not turned on. So if you want to display a certain segment one by one, if we're going to, just for the demonstration, if you want to, for example, turn on the LED segment 1 or A, we will switch on the segment A. So likewise, we can set another segment to high, so that we can, for example, display a certain figure or symbol that we want. For example, in this area, we are showing number 7, which is activated by switching on or setting the voltage high to segments A, B, and C. Since these numerical symbols are commonly used, each of their outcomes are already laid by the truth table. So this is the regular truth table of a 7-digit segment display. To activate the segments that represent 0 as an integer, we should turn on A, B, C, D, E, and F, and leaving aside G. So that means activating A, B, C, D, E, F, and leaving aside G. so that these segments will turn on and we will be able to see the symbol 0 as an integer. Okay, another information, there is another technique that we can use to show our desired outcome without switching these segments individually by using combinational logic circuit and a 7 display decoder, which requires us to combine commands or switches in one switch, so that we can, for example, if we want to show 0, we will have to just click a certain switch and we'll be able to show it without individually switching on and off the 7 segments. Okay, so we're going to make a kernel map for the table that we have, which is the basic ones. So first what we're going to do is to make a kernel map for A. First we're going to A, B, C, and D. Okay, that's A. Then we'll make 16 cells box or diagram. Then we'll make 4 by 4. 1, 2, 3, 1, 2, 3. Then we'll put these labels. Okay, as you can see. And then for A, we have here 1, 0, 0, 1, 1, 1. Then we'll put here number 8's value, which is 1, number 9's value, which is 1 again, and then the rest is a don't cares, so we'll put X. We can include the don't cares in our mapping. So this is the base. We'll just put these. Okay, this one too. What else? We also have this, and then this. So that makes our K map for A. So we can conclude this or simplify this map as A plus C plus B, D plus not B and not D. Okay, so this is what we're going to do for the rest of the values of A until G. Okay, time to design our computational circuit diagram with a simulator online. So after designing these circuits, they will be connected into the nodes of the module of the 7-segment display. And we have learned, making our kernel map, that these circuits have certain combinations that will act as switches for each of these segment nodes. So we formulated that A is equal to A plus C plus B times D plus not B times not D. B is equal to not B plus not C times not D plus C times D. C is equal to B plus not C plus D. D is equal to A plus not B times not D plus not B times C plus C times not D plus B times not C times not D. E is equal to not B times not D plus C times not D. F is equal to A plus B times not C plus B times not D plus not C times not D. And lastly, G is equal to A plus B times not C plus not B times C plus C times not D. And so in this video, we learned how to program our 7-segment display decoder using BCD.